Okay, so this is our introduction to classes in C++. It's an object-oriented programming paradigm. So classes, understanding of the classes is very important. So when you talk about object-oriented programming, we'll be discussing a lot about it today. But in a rough overview, an object-oriented programming is nothing but envisioning object within your programming paradigm. Everything is an object, and then you establish the relationship between the objects to create your modules, and also the objects offer multiple uh, convenience to the programmer, such as it contains certain attributes, it contains the functions, and the outside and from the outside world, I mean outside of the object, you can access the object using certain functions or using certain publicly available attributes. Let's move on and we will learn more about it. So the first thing first, I mean we have to learn the context of an object-oriented programming. So until this point in our C++ lectures, we have focused on exclusively on procedural programming. That means I mean, the conventional static procedural programming is something like that. You open a file, you write some just headers, and then you create a main function. Inside the main function, you add line by line instruction. So basically, it's very procedural. Like your compiler obtains the main program, and then it goes line by line instruction in the code to do certain work. So that's pretty much your procedural programming. Functions, methods, these are all part of procedural programming. So in the procedural programming, you can have the functions to add some modularity to the program. When I say modularity, it means if you write, suppose you are calculating, you are doing some multiplication. Okay, so you can do it in two ways. Number one is that you can whenever you need to multiply something with something else, then you do it by hand, I mean within the code itself. Every time you multiply, you do that. Or you can define a function called multiplication where you do the multiplication, that that uh, that work, that task, and you call that function multiple times. So that, I mean, using the function, that gives you makes your code very modular. That's number one. Number two is it makes your code little bit less error prone, because you are consistent. If you are calling the same function, you are consistent. Of course, you make a mistake in the function, then your errors will also be consistent. But you know what? This is very easy to catch any error if you write your program in a modular manner, like functions, methods, etc. Now, that gives the context of the procedural programming. And there is another type of programming that we are going to study today, that is the object-oriented programming. The object-oriented programming focuses on the data. I mean, for programming, you are basically working on the data in your application. So it works on data and functions that operate on the data. So it's all about data. Whenever you do any programming, uh, there are three things that you are accomplishing. Number one is digitization, that is very closely tied with the data. Number two is automation. So through programming, you can automate multiple things. And number three is basically you analyze through the programming, you analyze or you reinvent the opportunities within the data. That is applicable to any programming language, any work that you do in the software engineering. Data is a very important factor. So here object-oriented programming actually exposes you to handle the data in a much more easier way, in a much more modular way, and also uh, it can really impose certain certain domain terminologies, certain domain, not terminologies, it imposes certain domain specific restrictions on the data. If you don't want certain data not to be manipulated, not to be available to be manipulated by the user of the data, then you have the option. That option with object-oriented programming, you won't have that option mostly with the functional programming. So we will be studying that more. Stay tuned. So the procedural programming, I mean, if you change the structure of the data, for example, so your functions may change as well, you know. I mean, you have a you you change some, add some new parameters to the data, then you have to change the function. But the programs that are based on very complex steps in the function, then it may be difficult to understand and maintain, and also difficult to modify and extend those functions. So as a result, what happens? The program may not be accurate all the times, and your program may break easily. So those are the disadvantages, demerits of procedural programming. Now, when you talk about object-oriented programming, you already had an exposure to object-orientedness, that is the usage of the class. If you remember correctly, we talked about struct about 2 weeks ago. So basically, let me see if I find some example. Still, if there is an example, let's see. Uh, yeah, that's the example of the struct. Let me bring it here. So we talked about the struct and we wrote it in the inside the class itself. So you can see that we could create a structure involving the data. Okay. So you see, we have the data like the employee number, name, hours, pay rate, gross pay. These are the data points, data fields or attributes. And out of these attributes, we were able to build up a struct. Struct is nothing but a data structure. It's a step closer, it was a step closer to the object-oriented programming. So you had you learned you already learned what is struct. So class is very much like a struct, you know. So what struct does is allows grouping of the variables. Like if you suppose you have a huge data set, okay, you have a big Excel spreadsheet that contains an office environment, I mean, about an office. Let's say it contains the office location, it contains I mean, building information, it contains the employee information as well. So out of that particular spreadsheet, if you are interested to separate out different concerns, like employee can be one actor, building can be one actor within your model of the data, then you can separate it out by introducing the concept of a struct, because you can group certain fields inside the struct data structure. But class, I mean, it is like the struct, but variables and functions in the class can have different properties than in a struct, you know. So it is still not clear to many of us. Maybe we are going to elaborate it more, but just understand struct is like you build a structure, and but in the class the you still have a structure, you still have a function, but it has a lot more opportunity within it than the class. It has, I mean, you have more control on the variables and the functions to interact with the variables if you define the class. Now, whenever you have the class, you should think about the object. So object is nothing but an instance of the class. So if you think about, let me give you an example. If you think about a building, okay, so let me open up the pane, just a second. So it is okay, pointer. So suppose you have a building, right? You are passing by a community and you see lot of buildings in the community. Okay, so these buildings, they follow certain plan, right? Plan is called, I mean, blueprint or plan, whatever you call it, some plan, planning material. Usually the architects of the development company, they manage that plan. So you can think class as the blueprint of the plan or the plan. So when you build an object, you write the program. Class is the tool for you, is the planning tool. Basically, it contains all the blueprint of your objects, and object is basically an instance of this particular plan or blueprint. Just like you have a plan, then you can have lot of buildings out of that plan. um, I mean, out of that blueprint, out of the you can have, you can build, your builder can build lot of houses out of that same blueprint. Similarly, you write a class in your program, then you can build lot of objects out of that class. And so object is defined as an instance of a class in the same way that variable can be instance of a struct. Okay. So that's pretty much our definition on class and object. Now, again comes to the analogy of building and blueprint. So essentially, this thing, this thing is the blueprint of a house. This is the plan or blueprint of a house. This is something, it looks like a class in your C++ code. It is analogous to class. Whereas the building, these things, these are the instances of this plan, right? So these are essentially the objects. I mean, in the programming paradigm, these are essentially the objects. So that is our concept about class and object. So whenever you talk about class, it has two things, you know, class or object. You can let's I mean, let's think about an object, right? Suppose we have an object called animal. Okay, we are representing animal as an object, so we can call animal. In the programming language, let us say we are representing animal as an object. Then, you know, there are multiple attributes. They can have attributes. Every animal, including human, have attributes, and they have behaviors, right? So for example, let's start with very simple attributes. uh, let's say uh, number of hands is an attribute. Okay, number of hands, let's say we can tell the has if it has some wing, let us say. Not all animals have wings, that's why has wing. That's a, it's a boolean kind of thing. And on the behavior part, you can say eat is a behavior for animal, or talk is another behavior for any animal, right? So these are the attributes, these are the behaviors. Now, this is the animal object, but when you think about its blueprint, animal class, then you define these attributes as the member variables in the class. Just like struct, you define some member variables. So in class as well, you define the member variables. And then for the behaviors, you define the functions. Like in C++, you can define a function, right? You can define a function or method. Uh, Again, a function can be of two types. Number one is it can return some value, return some data type, or it may be a void function. It won't do any return. So same thing applies to the class. Inside the class, you can have the variables and you can have the functions or methods. So those are the basic uh, contents of a class. When you think about a class or object, those are the ingredients of the class. And when you instantiate that class, you find an object. Those variables become the attributes of the class, attributes of the object, and the functions are like the behavior of that object. So why the classes in C++ is superior to the struct? The main important thing with the class is very simple. That is, it provides you a feature of data hiding. You know what is data hiding, by the way? So you define a class, right? I mean, like for example, let's give an analogy with a car. So suppose you buy a car, I mean, any manufacturer, any leading brand, whoever manufactured it for you, you buy a car. So immediately the first question comes into your mind is that how can I start my car? So basically, there are cars that has the keys. There are cars that have no keys. I mean, the ignition button. So you can have any of them. So that is the way you start the car. But internally, there is some wiring with the engine, and that basically, that wiring, through the wiring, there is an electrical circuit, and those circuits play a huge role in starting up the car. Imagine the situation that you just sit in the car, open the engine, and then you start finding the wires, and then you have to do certain things with the wires that will start up the car. So why it is not a good way? Because that way you can mess up a lot of things inside the car. You can mess up the engine potentially, engine circuit. So that's why the manufacturer gave you certain visible buttons or the key location keys to start up the car. So if you think about the uh, objects or classes, they are the same. I mean, you have multiple data in the object, but you, as a programmer, you don't want to give access to other outside world to those data members, because those constitute the internal structure of your object. So what you do instead is you expose certain functionalities, and then you can you and so that your functions will be the only way for external agents, whoever is calling your object, to manipulate the data. So the data manipulation will be guided by you, the programmer, not by external agents. So that way your objects will be compact and it will maintain its identity. So for example, you have a bank account object. Let's say this is your bank account object, and then in the bank account object, your you have certain attributes or variables called maybe the balance, maybe another attribute, account number, account holder's name, and balance. But then you don't want other people to access those three variables. Why? Because uh, I am a programmer, and by mistake, I'm calling your object, and by mistake, I change the name of the account holder or change the balance. Then your bank account will have some bad consequence, right? If your balance changes. So that's why actually you expose to outside world only certain functions. Let us say for bank account you can expose check balance. That way outside the world, someone who accesses the class, some programming paradigm that accesses the class can only check the balance, or you can have like uh, change balance. I mean, add deposit. let's say deposit. Whenever you deposit, call the deposit function and deposit some money, say pass an argument of amount that you were depositing, then within the class internally there will be functionalities that will basically change your balance by a function within the class which is not publicly available outside. So that way class will maintain its integrity. So that's called the data hiding. You don't want to expose everything, all attributes, all functions within the class. You want to expose only those that are needed. Then I mean, along with the data hiding comes the public interface, members of an object that are available outside of the object. That's what I was talking about. This allows the object to provide access to some data and functions without sharing its internal details. In your car, I mean, your button or, I mean, ignition button or the key to start the car, those are the two public interfaces of your car that you can use to start up the car. I mean, if you do that, then basically uh, this car will give you the access to the engine. Suppose you want to see the if the engine starts up, or you want to see the mileage. Those are the return, and those are the functions which is returned by your engine. So you switch on the car, and then you can see on your dashboard a lot of information. So those ignition button or the key, those are the public interface to for your engine in the car. So same thing goes for the object. So let's see, let's go dive into more technical details. So far we have discussed a little bit in a very abstracted way. Let's jump into some details now. So how do you write a class in your C++ programming language? So the answer is let's bring up our book, I mean our programming pad, and then we can say uh, class example.cpp. We can start with that, you know. So suppose we are uh, trying to define a rectangle. So I mean, we can start with, and that's why we are going to define a rectangle class. So we can start with the simple input output stream and using namespace std. I mean, there is no exception to that. I mean, these ones. So once you do that, now you are not jumping into the main program. Now you define the class. The way you define the class is by using the keyword class and then the class name. Class name in our case is rectangle. Okay, so that is our class name, and then we create and we add some brace, curly brace, and then we just put a semicolon. This is the shell of a class. Just like the shell of a main program we defined, try to define a class in the as a first step you define the shell of the class. So you have the keyword class, you have the class name, and you have an opening and ending curly brace, and then you put a semicolon. So now inside that, let's start defining the functions. I mean, the attributes and functions. So the attributes, I already told you that there can be two levels of attributes. One is publicly available, another is not publicly available. So whichever attribute is not publicly available, we call them private. So you can say private, and then you can say, let's say the variables are width. Sorry, yeah, that's fine. We can do in this way, private, sorry, you can do colon. So these are your private variables, double width, and then you can do double length. Then publicly accessible variables, you can say public set width. This is a function that will that will set your width of the rectangle, and the data type that um, sorry, again I have to do a colon, and then we can do set width as the void non value returning function. Then we can define set length. So from the external side, you can set these attributes, length and width, because these are private variables, so this won't be available to the external agent. Then you can have the get functions, which are basically the area, length, width, and area. So you can define this as follows. So you have width, length, and area. So this is your definition of the class. So you have a class where you have the private variables you are not exposing to outside, and there are public functions which are exposed to outside. Now we have to do the concrete implementation of this set variable. These are called the setters, and these are called the getters. Setters are often called the mutators. Mutators means the functions by which you change the attributes of the class. Those are called the mutators. And get functions are called the accessors. You access the values of certain variables within the class using the get functions or mutators. Those are the definition. So once you do that, let's do the concrete implementation of those functions. So we write few more lines next to it. So we are doing the implementation of set width, and so there is a variable passed to it, w, and then width is w. That means this width is the width of the class. The class variable is changed here. The width is assigned. And then length, same thing for the length as well. So you can do it like this. So this is your length. Then comes the getter. So you can do get width, and then you can do the uh, get width, and then you can do the get length. I mean, it's pretty simple, but you have to be mindful about how you are writing. It's a matter of practice, how you can get to write this function seamlessly. And then get area, this is something you are calculating inside the class. Going to explain you what does this keyword mean. You can see that you have the rectangle double colon. What does it mean? It means your set width function has a scope within this class. Okay, so it is a way to specify that these are the member functions of this class. Whenever you do a member function, you always use the class name, then double colons, and then you specify the function that you have already defined in the class. Inside the class, you can do this concrete implementation inside the class itself. You could do it, nobody could prevent you. Like if you do it in this way, let's say double x, and then you can say um, width equals x. That is also good. But that way, I mean, you are defining too many things inside the class. Your code will be wordy. Essentially, your code will be contain lot of words. People do not want that. People want classes to be very well defined and very precise. So this gives you the precision. Of course, this is a choice of the programmer. This is something within the engineering best practices. So, but you can redefine these classes. You can define these classes outside the class body itself by calling the rectangle, in this case double colon. That means you are saying that set width, I am writing the code for the set width, which is a member function of the rectangle class. Same thing applies to remaining stuff. So that's your class. That's how you create a simple rectangle class. Now, how you can use this class? The answer is pretty simple. Now comes your C++ expertise. You write your main program that you have learned so far. Return 0, the shell of the C++ program. And then what you can do, you can instantiate the class, the object. This is how you can do this. Rectangle, the name of the class, and then you can say box, let us say. Now, um, this is the way you do it. It is just like the class is just like a data type. You can see here, class is just like a data type. For example, if you have int is a primitive data type, so it has only the value. You can assign some value to it, certain values. I mean, not a double. You cannot assign a double to int. But then you have double, you have float, you have string. But this one, the class is a much more complex type of data type because it has some attributes, it has some functions. So it's a specialized data type. It's nothing but a data type, but it's an object data type basically. So you have rectangle and then box is the instance of the rectangle. So in this particular expression, rectangle is the class name and box is the object's name. So here box is the object. We are dealing with the object box. So then we can define the width and length. So you can say double length, double width without any issue. So now we are getting to specify the the things. So what we can do here now, we can do some interactiveness, add some interactiveness to the code. Let's say you do it in this way. You can do W and you can write L. Okay, so you are basically inputting your width and length. So once you get that, what you can do, you are calculating the, you have to calculate the area after all. But the way you should do it, you have to call these set functions to set the width and length within your rectangle object. Here is how you can do it. So you do W, you do L. Okay, so you set the length and width. See, you created an object box, then you are calling the member functions. The way you can call the member function is by putting a dot here. So if you just put a dot on your VS Code, you will see these suggestions. You can accept set width, and then you can put W as a parameter to it. So same thing applies to the set length. So ultimately, we are now going to calculate the get length and area of the box. Here is how we can do it. So you can have this cout statement, and then you can say rectangles data, width, length, and area. So box, you are doing just box get area. So these functions you are calling. Where is the get area? I didn't specify the get area, so I have to write it somewhere. I missed it to write. So let me add this one too. So beneath this, I can specify get area, and then so you have this class definition, you have the member function definitions. Now you have main. Here you are instantiating the class to create the box object. Then you get the values of length and width stored inside L and W, I mean W variables or identifiers. Then you call this box function, box like this is a object, and then call its member function set width and pass W here. Again, call the member function of box set length and pass the length here. Now you are creating the output like you get the width, like there is a get function. So get the width for this particular instance. The width will be whatever you have set it here, and get the length, and then get the area. Area is nothing but this one. So that's how you can write a class. So once you do that, let's save it and let's try to run it. So let's create a terminal. So then we can do g++ dash o. What is the name? Class example dot cpp. No, we should do cpp is the file that we are compiling. Uh, Class example dot exe, that is your executable file, and you compile it. It is compiled. Now you do class example dot exe. That's how we do it. See, this program will calculate the area. So here it comes here, because your program always hit the main program. It does not mean that it did not compile it, but when you execute, it executed by the main program where it has already created an instance of the box object. I mean, box, you created a box object. So let's say the width is 20 and length is 40. So you can see the area is for 800. The area of the rectangle is 800. So that's pretty much a simple example on how a class can be programmed and how a class can be instantiated to an object, and you can calculate the things that you can do with the object. So this is a very simple example. So going to the abstraction, like I mean definition, your class is like the class keyword. This is a keyword in C++ with a class name. In our case, it was rectangle. Then you declare the variables, declare the functions, and then I mean that's the same thing we have used. I don't need to repeat it. So that's pretty much it is. And then you can note that we have used public and private functions here. So you have the private functions. That means, let's say if I come here for some reason, I have W, right? Can I just say that box dot W equals whatever W? Can I do that? See, there is an error because it says there is no member, means there is no public member W, or I think width. So if you do the width, it says that width is inaccessible. You can see inaccessible means it's a private member. That's why it is not accessible. So you cannot use it. I mean, only way you could use the width, access the width, if it were public, otherwise not. So that's an important property of C++, and that's an important advantage of writing the code based on the classes in C++. So that's about it. And then you can have more access specifier. It can be listed in any order in the class. I mean, um, you don't have to write private in the top. You can write private at the end. Um, I mean, if you don't specify any I mean, any access modifier inside your code, by default it will be private, meaning that if you have this code, for example, and you did not specify, not this one, I wanted a different program. Yeah, this is the one we ran. So you may not have this private here. If you get away with this, still it will compile, it will work. But at the same time, by default, this variable, if it is not mentioned as public, it will be private. So evidence is if you try to do box dot width, you cannot get access to it. See, it inaccessible, it's still private. So it doesn't matter if you write the keyword private, it is always recommended that you specify explicitly what is private, what is public. If you don't specify something as private, by default it will be private unless you specify it to be public. Okay, so that's pretty much about the properties of the accessors, properties of the access modifiers. So let's go back again. Let's see. So here they can appear multiple times in the class. I mean, you can have, um, you can also alternatively define private width equals a private double width, private double length. I mean, use the private multiple times you can use, or public, it doesn't matter. And so that's about it. And then you can use the constant with the member function. Const appearing after the parentheses in a member function declaration specified that function will not change any data in the calling object. So typically the getter functions, the accessors, do not change anything. So it's a best practice if you mention const, because it is not going to change anything in the data. So sometimes, people different people write program differently, and sometimes out of some wilderness of thoughts, people may do the get with function, but without doing any accessor property like retrieving the width. They can set the width. Nothing in the programming language can prevent that. But if you mention that it's a const, I mean, after this const keyword, that is the importance of using the const keyword, so that nobody attempts to do anything to to change within the class, within the function. So that's the blessing of the const keyword. And the member function we already defined, so you can define any function in this way. So we already spoke about accessors and mutators. Accessor get functions are accessors because they don't change anything in the code, but they retrieve some data. And mutators are the changer, basically, that modifies the value, that creates a value within the function or modifies the default the values. So those are the mutators and accessors. We also defined the instance of the class. We already went through it. I'm not going through it twice. You can avoid stale data. I mean, some data is the result of a calculation. In the rectangle class, the area of rectangle is calculated like this. If I mean like this one. If we use an area variable here in the rectangle class, its value would be dependent on the length and the width. If we change length or width without updating area, you know, then area would become stale. Okay, to avoid stale data, it is best to calculate the value of the data within the member function rather than store it in a variable. So if you basically, that's the scope of, that's the use case of adding that area function, calculate area function, because you change the length and width, but there is no use of the area until you apply those length and width in the class itself. So within the class, if you have those member functions defined, then you don't have to mess with that outside the class. So that's the point. I mean, if you want to avoid the stale data, that's why it is best to calculate the value of the data within a member function rather than store it as a variable. So let's give a break for 10 minutes and come back, and we will iterate more on the class. So yeah, that's pretty much it is. Yep, go ahead. Yeah, for today. Next week we will be doing attendance 7. Okay, yeah, sure, no problem. So I'm putting a timer here. So we'll come back in 10 minutes. So the next thing is the pointer to an object. So you were doing the C++ programming, and now comes the pointer. That's an important consideration when you work on this. So let's do that. So basically, you can define a pointer to an object in this way. So you have rectangle, and then you have the pointer, and you call it null pointer. So that's the way you create a null, basically a null object. So that's not an object, of course, that's a pointer to the area, to the uh, to the rectangle object. So let's move on. So this when you define the pointer to an object in this way, it can access public members via the you can access the public members via the pointer. So basically what you do, pointer is defined in this way, and you know it's already that we have this and symbol, that's reference symbol. This is essentially the memory location where your pointer is where your object is stored. And then you do pointer set length. So basically what you are doing, you create an object, store it in a memory that is stored by default, and then you call it, and then you set, I mean, you basically, this function, this arrow symbol, this basically set the values of the pointer, and that's pretty much it is. I mean, you do the pointer, and then you uh, do the get length. I mean, basically that's the way you can use the pointer on this particular example. Just a second. So that's pretty much it is. Um, that's how you can do use the pointer to your particular uh, example. You use the pointer. So we can, in fact, we can move ahead and run a, I mean, create a code for that. Let's do that. I mean, that's the best way to learn it. So let's create a um, file called uh, class pointer.cpp. Okay, so that's pretty much it is. So let's define a class which is less obvious right now to most of us. So what we can do, basically, we can we can repeat the same class actually. We don't need to write a different class. So we do this, the same class I have written before. I'm just adding it over here. Okay. So now what we can do, we can define our main function. I mean, to call the class basically. Now, a rectangle that can be a box. I'm saying that it's kind of a, you can use rectangle object in order to define different room spaces in your house. You can define a kitchen, you can define a bedroom, you can define a den using the rectangle object. So let's write the main function first, the traditional way that we learned here. So return 0, that's the shell, and complete the main function. So now we can add the code to it. So first thing first, we can do a do it in this way. Like there are three areas I told you that will be covered. So let's say the number is the number basically. So then you have the total area, you have kitchen, you have den, you have bedroom, three things. So you can do in this way. I mean, dynamically you can create the objects in this way. You can simply do like kitchen, new rectangle, bedroom, a new rectangle, den, a new rectangle. So you see the new keyword. This means you are dynamically creating the object. That is the difference you are making here. So you have the kitchen, I mean, this is a pointer, and when you have the pointer, you can have opportunity to dynamically create the object. So you are creating a new object and store it inside the memory, and then your star, I mean, these things are pointed to the location of that address, memory address. So from there, actually, you can poll for the data that you want, the length of the keychain. I mean, all those parameters. So what's the keychain's length? You have the number, and then I mean, what is the keychain's width? You can use the same number, same variable, but you have to set it properly. So this is the way you can set the length. I mean, you have to put an arrow sign because it's a dynamically allocated object, and kitchen is really not a variable, it's a pointer. It's not the real kitchen, it's not the instance of the rectangle object, it's the pointer to the instance. So that's why you are dynamically allocating, creating the rectangles, and then you are just pointing your I mean pointing the set length variable for the kitchen and assign the number here. So that's all about the kitchen. Now we can do the same thing for the bedroom. So we can poll the values for the bedroom dimensions. That can be done in this way, um, same way as kitchen. So what is the length? You put the number, width number, and you are doing the setter and getter, and then you can calculate the total, and then you can do the den as well for the house. So same thing, the numbers for the den as well. This is the way you can do, and then finally you can calculate the total area of the three rooms. So basically you can do, you have to use the get area functions. So you do kitchen get area, bedroom get area, and den get area, add them together, it's the total area. So once you do that, you can display, and then once you display, then comes the cleanup process. You created dynamically allocated objects, so you have to delete them. So how do you do that? You do first you do the delete function like this one, but then just deleting won't I mean it won't solve the problem until and unless you set the null pointer back here, just like this. So that way your pointer won't contain anything. So that's your whole code basically. So what did you do? What did we do? Let's see. I mean, the first part is pretty straightforward. We just mimic the rectangle class. No, I mean, no new thing there. But here you can use the pointer and you can point them to the null pointer. That is the first step. Then you create the new rectangle object. I mean, you are dynamically allocating the rectangle object, I mean, the kitchen object inside the memory shell. You do it for bedroom and den. And then finally, you get the numbers and set the attributes for the kitchen and I mean kitchen for the bedroom and also for the den, and then you get the area, total area, and you calculate the total area, and then finally you clean up by deleting each of the dynamically allocated objects, and then also you set them back to the null pointer. So those are the steps. So if you run the program now, I have to save it, of course. So if you run the program, so we have to compile it. So you see I am in the same directory as the code. That's why I can store the file here. I can compile it without any problem. So let's say, what is the class name? Class, I think, let's find the class name. We wrote the class name as class pointer dot exe, and the class name is class pointer .cpp, and then we can compile it, and then we can run it. Class pointer.exe. So what is the kitchen's length? Let's say 10, 10 width. Bedroom's length, let us say 15 by 12, giving some very rough numbers. 8 by 5. So the total area of 3 room is 320. So that's how you can do it. So it's a very small 1 bedroom apartment kind of thing. So that's pretty much it is. So that's the way you can write the program, dynamically allocate the memory, and then you have to clean up after it. This part is very important. Many people forget that. So that's pretty much it is. We don't need to have very worried about this. 13.4, why have we have private members? So we have already discussed about it, when you do not want the external objects, external agents, whoever is calling your object to manipulate your private data, then you don't, you can make the members to be private. Uh, so the data access can be done by the public functions only, and public functions define the class's public interface. So that is the important. I mean, that is a very good like importance of the classes and of course the object-oriented programming. So you are making it like uh, I mean you have the data hiding property in the object-oriented programming, and also the it gives you uh, something called encapsulation. I should write it down. Uh, Encapsulation, which means you are encapsulate the private data into private and public members. You can do the access control, and you can put together your attributes, that is the variables, and also the functions within the same roof within the class. So this is called encapsulation. This is one important um, step or important pillar of object-oriented programming. I mean, when people do job interviews for a C++ programming or any programming role, in fact, uh, they get questions about these properties of object-oriented programming. And so whenever you say encapsulation, you have to remember two things about it. Number one is you are defining the attributes and functions within the class and within the object. That is number one. Number two is you are doing the access control by implementing private public kind of access modifier. So these together constitute what is called encapsulation in object-oriented programming. Now, so I mean there are multiple explanations with the encapsulation. So then coming to the separating specification from the implementation. So when you place class declaration in the header file, I mean, we are switching to a completely different topic. So the what we did in our class definition, you see here. So you can take the rectangle class. So here, this is the core definition of the class, you know. So if somebody asks you how this is this class defined, you only refer to this particular part of the code, because I mean that is one of the important features of object-oriented programming, that you don't care about how these methods are implemented. Somebody implemented it, you don't have to care. You see that you can get the width, you can set and get the width and length. You can get the area, you can get the width, you can get the length using these functions. Okay, so but how do you make it more modular? I mean, I know the class is already modular. You can make it even better because you see here IO stream, this is essentially a header file. You can create a similar facility, similar header file for the class that you have created. Okay, so here is how you can do it. You can simply just take out this part, copy, create not this one, I'm sorry, it should be the one we have written in the class. So here it is. Why it is not visible? No, not this one. Class pointer, right? Here. So what we can do here, we can simply take it out and create something called a file, new file, and we can say uh, rectangle dot h. Whenever you say dot h, that means it's a header file, you know, rectangle dot h. It should be rectangle dot h. It should be. So you create the file, you paste it there, and also you don't need to do using namespace std because you are not doing any std here. You are not writing anything here. But still, I mean, it may be a good practice to do it there. So where is our rectangle function after all? So we did, it's not the rectangle, it should be programming example, something like that. Let's see where did I lose it? So you have the class pointer, this one. So we can get rid of this line, these things. We can still include these back into the rectangle class. Where is the rectangle class now? We can, from the next class, we have to create separate files, separate folders for each class. That way it will be easier to handle. So anyways, so this one. And then what you do here, you go back to your um, program example, I mean, example class or something, whatever you created, class pointer dot cpp. Is it the one? Kitchen. Yep, that's right. So what you can do here, you can also include, sorry, include your rectangle dot h here, you know. So that way, why it is not found? Your locations, please update your include path. So you can squiggles are disabled. Okay. So your include path needs to be updated. This is, I believe, um, this is a setting. So you can do include path. Where is the include path? Compiler argument, not that one. Include path here. So it should be the workspace folder, but why it is not one include path per line? So you can do like your, it should be there. I don't know why it is missed. So you can do it like that. Sorry, here. So you can do it like this. So if you do that, and then if you update it, is there any way to update? Let's say you go back to your class pointer. So your include path is updated, but why cannot open source file this one? So uh, translation unit, this one. I don't know why it is not updated. Let's see if we try to compile. So next question should be, how do you compile a code with an include path in C++? Compile a code with header in C++ using G++ if you want to do that. So you can do it in a simple way. I mean, you can do G++. In fact, you don't need to use anything here. So you can still keep it the same. Let's see if it compiles. So it compiles because, I mean, this is something related to VS Code. I hope that we will be able to solve it. I will try to work on this and let you know in between today and next class how to get this red line disappear from here. But for now, just assume that it is correct. It is correct because it is compiling here. Now we have to do another trick here. We still have these things here, right? So what we need to do, we can simply take it out further. You can take it out, copy, and then you can create what is happening here. Okay. Now you can simply you can add a new file called rectangle.cpp. Inside that, you can paste this one, and then you will have errors. But what you can do here is include rectangle.h. So that's your solution. So that way you won't be. So now you can see that this rectangle.h has become the part of this code by this include. Same way as we do for input output stream, IO stream. So once you do that, you go back to your where is it? Your class pointer here, and then what you can do, you can simply you don't need to use this one anymore here. Oh, it should be rectangle. That's the reason. So that's the problem. So you can get rid of these. You can get rid of this part because you already have it. So there, let's see. You got rid of it, but no, I think you still need that include stuff here. Include rectangle.h. So that is it. So now your rectangle is updated. It should work now. Identify rectangle is undefined. How come rectangle is identified? So you have the include path. So let's see where it is the include path. So it should be rectangle.h. So your identified should be defined here. How come it is missing? So PQR here, rectangle.cpp. That's not the one we want. We want rectangle.h. So you have the rectangle here. So how come it is not picking up? So yeah, now it is good. So it takes little time. Yeah, that's right. Thank you for pointing it out. Yes, Harrison, this is good. Good catch. Thank you for following it so closely. So that's it. So once you do that, this is the way you can run the code. You still have this one, but then on the top of that, you should put rectangle.cpp as well, so that you include everything and then you run it. So you have the same thing. Let's change the name of the executable so you know that we have changed something. So we can do it like this: rectangle class pointer 2.exe. So that's it. And then we can run class pointer 2.exe. Now you can have kitchen's length 10, kitchen's width 10, bedroom's length 15, width 12, den's length let us say 8, width let us say 6. So you get the nice area, total area. Everything works fine, but you made it more modular. You introduced the concept of the header file. This is the essential skill set for your C++ code writing. So what we did here, we have not done anything new. We just separated out the class definition, put them together inside a file, called rectangle.h. H stands for header. So this one is the file. So you put it here. So people will look at your header file and see what are the basic, attributes of the class, how the class is defined. They won't even need to look at the other one, that is rectangle.cpp, this one. This is the concrete implementation of the member functions. So you define it here. This also does not need to be in your implementation. And then finally, you go to um, your code, that is your user level code, that is pointer, where you refer this one, and then you define this one, define everything here, and then when you compile, you link your you link your implementation of the rectangle class, and then that way you can build the program, you can run the program. So it's that simple. It's not hard. It's not very like obfuscated stuff. It's too simple, straightforward. So that's where we are. You can use the inline like inline functions. I mean, inline functions are inline means within the class declaration itself, you can do the inline. So the way we did it, it's not inline. It's here. What we did here, we have an external program called this one rectangle.cpp. So we have done it externally, but alternatively you could go inside your h file, and then let us say you could define them here itself under the public. You could define these functions. There is no barrier. So you could what you could do, let me see there. So let's say you want to do it in line. So you do it there and you go there and you set them up here. Okay. So let's say we are doing it in this way. We got it here in this way. So we have to be a little bit careful. No, it's not good. It doesn't look good. So that's why not feeling comfortable with this. So anyways, so this one, but this time actually you don't need to include your CPP file anymore, the rectangle.cpp anymore inside your compiling unit. So you can do like this. Oh, there are errors. Let's see what is happening. Um, extra qualification rectangle. Oh, I see what is going on. So you can do get length const, but that should be fine. What is happening? Oh, okay. So you don't need these keywords anymore, you know. So what you can do, uh, you can replace rectangle with nothing. So you can do it, replace all. So because you are within the class itself, you don't need that class name colon colon stuff, because when you do it outside of the class, then you need that class name colon colon stuff. So you do it here, and it should be pretty transparent. So what is happening now? So you have extra qualification rectangle on member set width. Oh, what is happening here? Rectangle.h. I think I forgot to save it maybe. So what is going on here? Oh, class pointer CPP, that's fine. So why it is doing like that? Get area, I have already updated this one. So what is this rectangle.h? So you have this here. Now class pointer.cpp, where is my, why it is doing it? We have already done it. Let me save it correctly. And here rectangle.h, that is fine. We are calling this function. Then we should be all good to do that. What's the problem? So if you do that again, um, there are duplicate things going on. It looks like rectangle.h 4312. Let's see what is 4312. rectangle dot h 43. What is 43? Here, get length. I mean, there is no problem here at all. So what you do is you are defining those below that should be allowed, you know, but why it is keeping us at bay. So area, where is the area? This is the area. So 52 error, double rectangle constant. So 5212, where is 5212? 52, this one, get area, but then previous declaration rectangle get area constant. So what is happening here? So if we go to the rectangle, let's open it up again. So this is our function rectangle.h. So you have the rectangle class. You have everything defined in line, basically. Now, maybe this is causing some issue, rectangle.cpp. This one, let me remove it, delete, okay, remove constant. So where is the constant? So why, um, I mean, yeah, I can remove the constant, but this is something that we use for, oh, I see why we are removing, because we have not defined it in that way. Probably that's the reason. Let's see. So if we do that now, it's still causing issue. So what is going on? Rectangle double cannot overload it with rectangle set width. Um, so why it is, so this is 1612. What is 16? Uh, we are overloading something. 1612. 16 is this one, set width. Why it is causing trouble for us? Maybe what we should be doing, we should get rid, oh yeah, we should get rid of this and rely on the inline definition. Now it should work. Yeah, yeah. I mean, we should have removed constant from both areas, but and that also helps us. So if we get rid of this, that can probably also help us compiling the code. No, it is not helping us because it is thinking that we are redefining the stuff here. So if you do that, that's why it is inline. So set width, that is fine, get width. If we put constant here now, and then if we put constant here now too, and if you put constant here now too, let's see if that helps us to compile. Yeah, that compiles. So you don't have to write it, define it here, and then you redefine it here. So that's why it was treating it to be overloaded. So once you do that, you can run the program. Just give it a try. Class pointer to, yeah, it works as desired. So that's good. So that's the way we should write it in a more compact way. That is the inline notation. That's how we define the inline functions. Otherwise, you can always do the CPP way, like you define the functions in a separate file. For the best practices, I would recommend you to do the second one. I mean, not this one, the way right now we were working on. Inline definition is sometimes very, very wordy. You don't want a lot of things on your header file. You just want the bare minimum, the class definition on the header file, and then implementation of the class function, member functions. You can set it other place. That way, it will be very compact and very readable to maintainable code. So this is not a good practice. The other one was the best practice within the scope of C++ programming. So let's see where we are. So that's it. We did here. So yeah, these are the like pros and cons. So the next step should be the constructor, but I think I mean we should stop now. We should leave it for our next week's discussion. I would like to know if you have any questions at this point.